The semicircle is shown and folded to form a right circular cone so that the arc PQ becomes the circumference of a base, okay? And the diameter is 10 cm. We want to find the diameter of the base as well as to find the curved surface area of the cone, all right? So the story of this question basically is that we are taking this semicircle, and what happens is this semicircle, this arc here, we're going to fold it such that it gives you a cone. Okay, so the cone will look something like that. There'll be another cone. You're folding this to give you a cone. And the same PQ, this arc PQ, will form the circumference of another base. This is what I'm saying. This will be the semicircle. And you are taking this to fold it together. It's like you're folding up, like you're tearing open the wrapping paper of the ice cream cone, right? And it gives you the cone here. Okay, it gives you a cone here. So this arc is going to form the base of the cone. You can see that the same red line. Okay, so what it tells you is this. I mean, basically, this is forming the circumference of the base. So first up, right, how do we find the diameter of the base? First of all, if you look at this arc, you know that this is the key. Like it connects it's the commonality between the two figures, right? Let's look at how we can find this length of this arc PQ. Now, the semicircle is of a diameter of 10. So if you want to find the circumference of this semicircle, we know that circumference is 2 pi r or pi d. So this circumference would basically be pi d divided by 2, which gives us 5 pi. So it will tell us that this entire stretch here, this is 5 pi. Okay, the same length also represents the circumference of the cone. So it tells you that the circumference of the cone is also equals to 5 pi. Okay, the circumference for the base of the cone is also equals to 5 pi. So if you know that this is 5 pi, it also means that this is 5 pi because you're connecting this length together. Okay, now this 5 pi represents the circumference of the cone. And from there, how do you answer the first part, which is to find the diameter of the base? Now you know that as a circumference, a circle here, the formula for circumference is also equals to pi d, right? So 5 pi equals to pi d. Okay, where this d here will represent the diameter of the base of the cone. So dividing by pi on both sides, it will tell you that d is just equals to 5 cm. Okay, so the diameter of the cone, the base of the cone, this is equals to 5 cm. Okay, so that's the answer for part 1. Now, next thing is this. When you notice that part 2, we are going to find the curved surface area. So curved surface area of the cone, as we know, if you backtrack in your formula, you know that you need pi RL. Okay, you need R and L. So we have our R already now because our diameter is 5 now. So you should know that for the cone, the radius will just be 2.5. Okay, so how do we find the slant height? Now, what I want you to observe is this. When you are folding this semicircle together, you can just try take one of these and at home and cut out a semicircle and you fold it, right? What you do see is that the slant height, right, actually is none other than the radius of the semicircle. Okay, the slant height, you can see I put a blue line to show. When you fold them together, right, this slant height, in this case, because the diameter is 10, the radius for the semicircle is 5, it will tell you that the slant height of the cone is also 5. Once again, I'll just write it down here to make it clear to you. The slant height, or basically the radius of the semicircle, is actually equals to the slant height of the cone. Okay, because when you fold it together, when you fold this up, when this red color line outline forms the base, this radius of the semicircle actually forms the slant height of the cone. don't believe you just try it out. Okay, you just work it out in your, or just cut out a piece of semicircle and roll it up. When you get a cone, this radius actually forms the slant height of the cone. Okay, so with that, we also have the L. So L is equal to 5 cm. So just focusing on this cone now, the curved surface area of the cone is pi RL, which is pi times R. Now the R is 2.5. We're talking about the cone, not the, don't be confused between the two R's, okay? The L is 5. And with that, your answer should be about 39.3 cm squared, corrected to 360 feet. Okay? So that's the answer for part 2, 39.3. Going back to the question, the answer for part 2, the curved surface area of the cone would be 39.3.